Okay, so how do we determine which point along the curve is allocatively efficient? For simplicity, we've identified 5 points. We also eliminated A and E. A is all capital good production and no consumer goods. E, all consumer goods, no capital goods. We said those are not real life possibilities for the proper combination of output of goods and services. So that leaves us with B, C, and D. When you look at this on the graph, as I'm sure a few of you did on the previous slide, it looks like D is a dead ringer for allocatively efficient. And the reason is D ends up being just about 50% of the way between production of both products on the actual production possibilities frontier. So when you look on the production possibilities model, look on the graph, D looks like the dead ringer for allocatively efficient. But remember, allocatively efficiency is a normative question. It's subjective. Now, the correct answer is, well, there could be really 3 correct answers. It could be B, C, or D. And 3 different countries with similar populations, similar governments, similar political systems, similar availability of resources, similar trading agreements with partners, might choose any one of those 3 outcomes. So what happens is we have to fall back on something we learned earlier in the semester: marginal benefits and marginal costs. Okay, let's talk about allocative efficiency and how society determines which combination of goods and services, which mix of output maximizes happiness for that particular society. Earlier in the term, we talked about the rule of marginal benefits and marginal cost. Economic thinking is marginal thinking. Most decisions involve changes in the status quo. So when we looked at an individual, we said a person should consume a good or service up to and including a point where the marginal benefit of that consumption is greater than or equal to the marginal cost of that consumption. This also checked out when we talked about a society. We talked about an example of something like how clean should the river be, in this case the Schuylkill River. Well, as long as the marginal benefit of making the river cleaner is greater than or equal to the marginal cost, we should continue with that activity. If marginal cost exceeds marginal benefit, we're allocating too many resources to the production of that particular service. Let's look at this graphically. Whenever you're examining a new graph, make sure to identify what's on your axes. On the horizontal axis, we have quantity of pizza production and consumption. On the vertical axis, we have the marginal benefit and marginal cost of those same pizzas. Let's look at our marginal benefit curve first, our downward sloping marginal benefits curve. Okay, the first level of pizza production yields a high level of utility, happiness, satisfaction, gratification. So if we look at quantity 1 and we chase that up to our marginal benefits curve, the first level of consumption of consumer goods pizzas yields $15 worth of utility. However, happiness, satisfaction, gratification starts to fall. Our downward sloping marginal benefits curve, the second unit of pizzas only yields to society $10 worth of utility. And our third level of pizza consumption, pizza number 3, only yields $5 worth of utility or happiness. Why is the marginal benefits curve downward sloping? Well, we call this the law of diminishing marginal utility. The law of diminishing marginal utility actually helps us explain the demand curve, which we're going to cover in the future chapter. But for now, let's just sum it up by saying this. It's a typical human experience that as you consume more of a good or service, it yields less and less happiness, satisfaction, gratification. So if that's true for the individual, in this case, it actually is true for the society as well. All right, so our downward sloping marginal benefits curve. What about our marginal cost curve? You can notice that that's upward sloping, right? So our first level of pizza production only has a marginal cost of $5 per pizza. Why is this? Well, in the beginning of the production, there's lots of land, capital, labor, entrepreneurial ability to go around. So there's lots of resources available. So the cost isn't that high. But as we produce more pizzas, we have to take resources away from capital good production. Therefore, the cost of production increases. So therefore, the second level of pizza production has a marginal cost of $10. And finally, the third level of pizza production has a very high marginal cost, $15. So what's going on at quantity 1? If society were to stop producing and consuming pizzas at quantity 1, what would happen? Well, we really wouldn't be happy, because at this point the marginal benefit of 15 is much greater than the marginal cost of only 5. This signals to society, shift more resources towards the production of consumer goods, towards pizzas, and less towards capital goods. How about production level 3? In this case, the opposite is taking place. The third level of production, marginal cost 15, actually outweighs the marginal benefit of 5. In that case, we're overproducing pizzas, consumer goods. Not a good scenario. I think it's pretty obvious that X marks the spot, right? At 2 level of output, the marginal benefit equals the marginal cost. So for us, for our example, for this society that we're examining, and again, these numbers are made up by the McConnell textbook, so it's not as if you could have just pulled these out of thin air, right? These are just used to help us understand this important principle. The second level of pizza production turns out to be where the marginal benefits equal the marginal costs. So for this society, they should produce and consume 2 units of pizza. Now that we have the information from the previous slide, we know that society has determined through their marginal benefit and marginal cost analysis, their normative decision, that the proper level of pizza production and consumption is 2 units. Well, if we look on our table, that coincides with point C. Now, some of you may be asking, well, we only went through the exercise to determine the marginal benefits and marginal costs of pizza. How do we know, therefore, that the same works out true to be 7 level of industrial robots? Well, we can think about this logically. Remember, when society was weighing the marginal benefits of consuming another pizza, another consumer good, versus the marginal cost of producing that next level of output, they were weighing it against the next alternative, the trade-off in costs. Every time we produce more pizzas, less robots can be produced. Every time land, capital, and labor entrepreneurial ability is used to produce consumer goods, there's less available for capital goods. So, if society uses the exact number of resources necessary to produce 2 pizzas, there's going to be the perfect amount of resources left over or necessary to produce 7 robots. Therefore, point C is allocatively efficient. Now again, this is a normative decision. You would have to be given those numbers that I showed you on the previous slide about marginal benefits and a marginal cost to determine allocatively efficiency. Now, here's a really good question. Does a society's choice of allocative efficiency today have any bearing on future economic activity? Well, obviously, the question or the answer to that question is going to be yes, otherwise we wouldn't be bringing it up. So, think about this logically. We'll go over it in a slide or two. What are the implications for a society of choosing B versus C versus D when it comes to future economic activity, future economic growth. Okay, quick review of what we learned so far. Our production possibility frontier represents the best we can do for the time being. So our black curve here, all along the curve, represents potential production given our limited land, capital, labor, entrepreneur ability, fixed resource and quantity quality, fixed technology. Trade-offs and costs. If we want more of any one good, in this case, we want more consumer goods, we have to give up additional units of capital goods, and vice versa. Therefore, we can't simultaneously have the production and consumption of more of both. That would violate our idea of limitations, and it reinforces the second important idea of the production possibility model, trade-offs and costs. What about a point inside the curve? Any point inside the curve is attainable but inefficient, not putting to use all of our available resources, right? Anywhere along the curve, we're achieving full employment of those resources and productive efficiency. Inside the curve, we're not using all of our available resources. What about the possibility of economic growth? How can we eventually escape our current production possibility curve, the limitations of production?